12 general solving the focused informal practice questions 1.1. So here we have 3 rods that are brought close to each other 2 at a time. Rod A and rod B, they repel. So A and B. So A and B, they are repelling. So they repel. So they should be having the same sign. B and C. So B and C, they also are repelling each other, so they should be also having the same. So A and B and C, they all have the same sign. So here state and demonstrate that unlike charges attract and like charges repel. Which of the following statement is true about electric charges? Like charges attract, false. Unlike charges attract, yes. If a neutral object gains electron, it becomes negatively charged. If a neutral object loses electrons, it becomes positively charged. So basically 2 and 4 are correct. So charging a neutral body by touching it means conduction. And when a rubber rod is rubbed against fur, rubber, so here we have a rubber rod and here we have a piece of fur. So the rubber becomes negatively charged. However, the fur should become positively charged. The rubber rod became negatively charged because it seems that electrons were transferred to it. So because electrons get transferred from the fur that became positive to the rubber rod that became negative. A neutral metal sphere is touched by touched, okay? So we have a neutral metal sphere that is touched by a negatively charged rod. As a result, both will have the same sign because electrons cannot go into the sphere. So basically, the rod stays negative and the sphere also becomes negative. So negative and negative. During the process, electrons, so basically protons, they cannot be transferred. So electrons are transferred from the rod, as I highlighted here. The electrons were transferred from the negative rod into the neutral sphere. The sphere was first neutral, and then from the charged rod, yes, to the neutral sphere. So they are starting from and then to, so from the rod, from the charged rod in here to the neutral sphere. Eventually the neutral sphere will become negative because when I charge by conduction, okay, both objects will gain the same charge. So we have here a metal sphere is electrically neutral. All right, let's see. It is neutral. It is touched by a positively charged metal rod. So let's see what happens. As a result, the metal sphere becomes positively charged. Of course. Let me draw it. Let me draw another one. So the positive rod stays positive. However, the sphere also becomes positive. Why? Why does this happen? It's really wrong to think that positives, certainly positives, cannot go down. Eventually, the electrons from the neutral sphere were, as if they felt sorry for the rod, and they went onto the rod, leaving the sphere becoming, here I'm gonna have some positives because they leave empty or vacant places. So electrons were transferred from the neutral sphere to the positive rod. The positive rod does not become negative because it is too much charged by positive charges. So basically this transfer doesn't make a big difference, okay, but it does make a difference for the sphere because it was not charged, now it is charged by losing electrons, it is positively charged. So the metal sphere gains some protons, never. Electrons are transferred from the sphere to the rod, 100%. The metal sphere loses electrons, كمان correct. The overcharge of the system is conserved. يعني, do I have any electrons or any protons that disappeared? Just went with the wind, gone with the wind? أبدا. So basically I only have a transfer of electrons. They are only exchanging charges. So yes, it is the total charge of the system, يعني sphere and rod, they both gonna have the sum of their charges before and after the same. Okay, so that's also correct. So 2, 3, and 4. We have a neutral conductor that is an insulating stand as shown in the figure below. A negatively charged is brought only close, not touching it, to the sphere, but not touching it. No. Which of the following describes the resulting charge on the sphere? This is a really tricky question. However, I know when I have this negative rod, electrons gonna get repelled to the other side and leaving positive places onto this side. This is what I call polarization. So I have two poles, that's it. But did the sphere lose? Did it lose or gain electrons? No. So basically it's gonna keep having zero charge. Only the charge distribution gonna get gonna be different. So it will not lose electrons, it will not gain electrons. No, not charge, but polarized with positive on the right. Yes, it is positive on the right, that's it. No net charge, but polarized with positive charge on the left. لا مش على left, on the right. Okay, inshallah. Which of the following can electron move easily? They can move easily in a conductor. So glass, wood, and air are insulators, while graphite is a good conductor. Okay, describe the separation of charge by polarization. Polarization means only distributing the charges, right and left, attraction of electrons or repulsion of electrons. Which of the diagrams below best represents the charge distribution on a metal sphere when a positively charged plastic tube is placed nearby? So basically here I have positive, okay, eventually it will attract the negatives onto its side. Okay, so here I have, no, this is unpolarized, ماشي صار. Here it cannot repel the negatives to the other side. لازم النيجاتيف يكونوا here and the positive be here. However, we don't have it here. C, why is C wrong? كمان the same as this one. These are the same. Here, the positive rod attracted the negatives, leaving positive onto the other side. That is perfect. So insulator, where electrons they cannot move freely. So basically الجولد, iron, copper are good conductors. Only the plastic is a good insulator, is a bad conductor. Also distinguish between electrical conductors. Why is copper a good conductor? لأنه قلنا it has electrons that can move readily, not protons and electrons, only free electrons to move freely within the conductor. It always has a negative charge, أكيد لا, and it can be insulated. So charged rubber rods are placed near a neutral conducting sphere. So the sphere should be neutral, causing a redistribution of charge on the sphere, which we call the polarization. Select all the diagram below that depict the proper distribution of charge on the sphere. Now let's see why A is correct. A, here you have a negative rod, here it is negative. Onto this side, on the right, electrons were repelled, leaving positive, positive, positive. عفوا إنه I have 4 electrons and 4 positives. So this makes it neutral. However, so A is okay. B غلط. The positive rod repelled the negatives onto the other side, which is wrong. Negatives لازم يقعدوا in front of it and positive on the other side, which is not our case. So هاي مش صح. Here نفس القصة. Negative cannot attract negatives. They have to repel the negatives. So also كمان مش صح. In here, diagram D, positives attracted the negative onto this side and leaving positive onto the other side. Here I have 4 and here I have 4, which makes it okay. Diagram E is not really okay. However, positives attracted the negative, but here ما عندي شي. So the statement says that we have a neutral conducting sphere. It doesn't make it charged. So this sphere is charged. So no, it doesn't make it charged. So only A and D were okay. Now to differentiate between conductors and insulators and giving examples. Example of conductor is any metal, including, let's say, adding to any metal, plasma and graphite. Insulator, be very simple, plastic, wood, air. The major difference in conductor and insulator is that in a conductor عندنا these charges that can flow freely through the material, where insulators they prevent the charge from flowing through it. By the way, when I say charge, I mean electrons. So the charges أصدن فيها the electrons, the free electrons, because protons they cannot. And we're done with 1.1.